Hello, everyone. I am Crystal Graziano, and this is my presentation on blood vessels. So, blood vessels are the routes through which our blood, nutrients, gases, and wastes circulate our bodies. Arteries and veins both have lumens. All of our vessels have lumens. And the lumen is the tubular structure that is in contact with the blood directly. In arteries, the lumen is rounded, and in veins, it is collapsed. And the lumen is surrounded by the tunica interna, which is one of the three tunics that make up our blood vessels. And both arteries and veins have the same three layers, except there are differences in the characteristics. They each have the tunica intima, the tunica media, and the tunica externa. In arteries, they have smaller lumens, but thicker walls because the pressure from the left ventricle that is just pushing blood out is the pressure so high that they have to have the thicker walls to be able to sustain that pressure. And in arteries, they also have internal elastic membranes in between the tunica intima and tunica media. And they have the external elastic membranes in between the tunica media and the tunica externa. And these help arteries withstand that pressure as well. Veins don't really have the internal elastic membranes or the external elastic membranes. So the tunica intima or tunica interna in the arteries is made up of epithelia and connective tissue, and it allows, these layers allow bits to kind of transfer in between the layers. And if you look at like a cross section of the artery, the endothelium appears kind of wavy because of the smooth muscle constriction vigor from the endothelians or endothelins, the chemicals that kind of trigger constriction. The basement membranes in the arteries provide strength and flexibility. Okay, the tunica media in the arteries is the thickest layer. And depending on how far the artery is away from the heart, it depends on how thick the different layers are. Vasoconstriction and vasodilation happen in here because of the nervi vasorum. There are the vessel nerves that are located in the media and externa of the artery. The tunica externa in the artery or arteries is thinner than the media, except in very large arteries. It's a connective tissue. It also holds the vessels in place. If you didn't have the tunica externa that connects to the surrounding tissues, if you tried to like move around your arteries, they would just go crazy. The nervi vasorum and vasa vasorum are located here. There are different types of arteries. You have your elastic arteries, like the aorta and the branches of the aorta. And the most elastic are at the higher pressures. And they kind of, they branch out. And then you get your muscular arteries. There's not like a clear line, like these are my elastic arteries, and then draw a line. These are my muscular arteries. They kind of branch into areas, and the muscular arteries deliver blood to organs like your renal artery, your radial artery, your brachial artery, and your femoral artery. So as they branch out, it kind of transitions from elastic to muscular. Arterioles are super high resistance. They're very small vessels, and they have the same 3 tunics, but the thickness in the layers is diminished. It's like 1 to 2 smooth muscle cell layers. They're the primary site of resistance, and they like lead into the capillary beds where gas exchange happens. And these constrict with sympathetic nervous system innervation, or they dilate. They do both. So vasovasorum and nervivasorum sounds like a Harry Potter spell. So I thought I'd throw him in there. The vasovasorum is the small blood vessel network that is on the walls of the large blood vessels. So it gives them their blood supply, delivers nutrients and oxygen, and also removes waste. The nervivasorum is essentially the nerve system that run within the walls of the blood vessel. So our arteries have no need for valves. Our veins need valves because the arteries are such high pressure. The pressure from the left ventricle propels the blood throughout the body, and they carry blood away from the heart. They're rounded and elastic to allow dilation and constriction. They have thick walls. The oxygen levels are high in systemic arteries, but lower in pulmonary arteries. Next, we have our capillaries. They're teeny tiny microscopic vessels, and their capillary beds are like bunches of these capillaries throughout different parts of the body where gas exchange happens. So arteries lead to our I just had a brain fart. Our meta-arterioles, and our meta-arterioles have sphincters on them, and they help control blood flow. Sorry. Okay, so I'm going to start over with capillaries. There's a little bit of disruption. A capillary is teeny tiny microscopic vessel that supplies blood to tissues through perfusion. And basically that's just getting oxygen to all our different tissues in our body. Precapillary sphincters are smooth muscle cells that regulate blood flow from a meta-arteriole, and they exchange like gases and wastes and everything through microcirculation. There are many different sections of our body that have capillary beds, and the capillary beds are used when the tissue in the nearby area or that capillary bed services needs to remove waste or supply oxygen to the tissue. So what happens is if the tissue in the surrounding area of the capillary bed does not need to remove waste or gain oxygen or nutrients, what will happen is there will be a vascular shunt And that's where the precapillary sphincters shut, and they're normally in like a closed position. And what happens is blood will bypass the capillary bed from the meta-arterial all the way, it'll go through the thoroughfare channel and into venous circulation back toward the heart. And the meta-arterial is made of rings of sphincters at the entrance of the capillary beds. So if you look at the image, they're here, and these are the sphincters, and they kind of shut off the capillary bed. Venules are small veins, and a bunch of venules connect together and they form a vein to kind of feed into like a larger vessel, which is a vein. And they drain the blood from the capillary bed and they merge together to form veins. So there are different types of capillaries. The most common is the continuous capillary. It's got a basement membrane that is super tight, so not many things can get through the membrane. It's made up of an impermeable endothelial lining, which has like super tight junctions and very few intercellular clefts where they kind of come together. Except for in the blood-brain barrier, it has a thick basement membrane. There is not very much that can get beyond. It can get past that blood-brain barrier, which is super important. So small bits, water, glucose, gases, hormones, white blood cells can pass in and out of the plasma. Then we have the fenestrated capillaries. They have pores, and there are tight junctions, but it's not as tight as the continuous capillaries. There's like a medium permeability. If you think of the continuous capillaries, there's a very small permeability, if any. And then these are like the medium. It's used for rapid transport of products such as in the kidneys, small intestine glands, where things need to happen pretty quickly. It allows larger molecules to leave the plasma, but not the pores aren't large enough for blood cells. So finally, we have the sinusoid capillaries. These are the least common. They have large intercellular gaps, an incomplete basement membrane. They're the most permeable. So red blood cells and protein and plasma can move freely. They're usually found in red bone marrow, the spleen, and the liver. So next we're moving on to like the veins. The veins have tunics that are the same as in arteries, like we covered before. There's a difference in thickness. There's not elasticity to veins, really. The tunica media is thinner than in arteries because of the pressure. They're very low pressure. The tunica externa is thick and the lumen is collapsed. So most of our blood, 60% of blood reserved in systemic vein circulation is in the veins. The oxygen levels are low in veins coming from the lower systemic parts of the body, and it's higher in the pulmonary veins. And veins have valves. So because the pressure is lower in the veins, the tunica interna has folded inward and created these valves. And when we do things like we move around or we breathe, it pushes that kind of muscle contraction pushes our blood toward our hearts, and the valves open up to allow that to happen. And when the blood starts to backflow, they close because they're touching together, kind of like the valves in our heart. So hearing that the blood flow venous system, like I was saying, there are a few ways that blood flows back toward the heart. There's the skeletal muscle pump. And these are one way. It's like a vasoconstriction. And when muscles contract, it pushes the blood in the veins toward the heart. And then the veins close to stop it from backflowing. And then you have your respiratory pump. And that is the pressure in the thoracic cavity when you inhale, and the pressure in the abdominal pelvic area decreases, so the blood flows toward the heart. So when there's vasoconstriction, the smooth muscle of the veins constricts and it rounds out the collapsed vein. And what happens then is there's less surface friction. So there's less resistance, which helps the skeletal muscle pump circulate blood back to the heart. I hope this was helpful. And my fluid presentation is going to help you get an understanding of our blood vessels. Thank you for listening.